So last session, we talked about an important section about the objects, and that is their life cycle and their time span in which they're living. And as you know, an object actually goes into multiple phases and cycles throughout its lifetime, and inside that scope of it's actually. And as you know, the first phase or the first cycle that an object actually experiences is the construction time. But sometimes the instances and the objects are not capable of being fully constructed at construction time. And people actually use patterns like adding an init or initialize method of some sort and call those methods actually at some point of its the object's life cycle to make it fully initialized. And also the object, of course, at some point of its life is going to die and be recycled, and actually the memory should be cleared and freed up. So the instances and the objects, all of them has a life cycle for their own. And the simplest life cycle that they could experience is their construction by the constructor and their actually destruction time called by manually either by the programmer, developer at some point, or called by the IOC container. So actually, we talked about something named as bean post processors, and we said that how Spring makes some magics happen, all that magics about some annotations like auto-wired or other things. Also, one of the other magics that IOC container makes it possible and happen is calling lifecycle related functions on each bean. So apart from the constructor function, constructor method, which is the main and the initial step of a life cycle of an object. Apart from that, we could introduce extra lifecycle functions. We could introduce an init or initialize function that will be called by the IOC container when all the dependencies of the fields and the setter methods and everything has been injected to the bean. And it gives you an opportunity inside the bean to initialize some stuff that should be done manually inside the bean itself after all the dependencies are in place. And also, again, by using a bean post processor, the IOC container could call destruction and close functions, destroy functions, when your instance is going to die, is going to be detached from the application context and from its scope. So the IOC container has provided a bunch of ways actually that we could choose amongst them and define and introduce our lifecycle related functions. The first one that I'm going to use here, so as you know, the constructor will be called because it's actually it is a aspect of the language, not the framework, that the constructor should be called when we instantiate, and it will be called, and you can ask for a bunch of dependencies, maybe all of them, and do some initialization here. But if you need some more initialization when all the dependencies are injected, you could add a function by implementing an interface named implements InitializingBean. So this interface has got a single method that we should override it, and that is named after properties set. This will be called when the constructor is called and when all the auto-wired fields and setters, if there are any, have been called by the IOC. And at last, this one will be called to give you the chance to do some extra initialization. But here I just want to print something that prove and show that it will be called. So after properties are set inside car. Now, if I run it, it is taking some time. Okay. So that is the interface we implemented, and that is the function. It has got a single auto wire field. Okay, it ran, and you can see that after the car constructor, this function is being called. We could add a bean post processor of ours, like the last session, and show that it is actually being called after all the dependencies are being injected. We could also do that by printing the engine and proving that the engine is not null, meaning that the field has been injected. So you can see that the field has been injected, and then this function has been called. So that is one way of introducing an extra initialization phase, we could say. Now let's talk about the next interface which will enable our beans to be able of introducing a function, a method that should be called when that instance is going to be destroyed and be detached from the application context. And that is the disposable bean. Again, the disposable bean has this single method that we can implement it, which is named destroy, and that will be called when the instance is going to be detached from the scope and from the application context. Now let's say destroying a car. This will give the opportunity for the instance to cleaning up and all that actually detaching from the world stuff. And freeing up the stuff, the memory, and anything. So if we run, you'll see that it won't run. It won't call this function, the destroying car. And that is because, and one thing I should mention before that is that the destroy will be called the destruction lifecycle. Actually, that phase will be called if the scope is not prototype, because when you set the scope of some bean definition as prototype, it means that the instances created off of that will be passed to the application, and then the application context will forget about that instance, and it won't actually track the instances. And because of that, it won't be able to call destruction on those instances. And that is because memory management, and you have to manage the destruction on prototype bean definitions yourself. But if it is singleton or the other scopes, custom scopes, also inside the custom scopes you have to manage them. But if it is singleton, it will be destructed once the application is being destroyed, because a singleton is unique and it will be instantiated only once per application. So it should be destructed when the application is going down and is going to die. So, but again, application finish here, but it is not calling the destruction. Maybe we have something to do here before the application dies, even before the JVM that is running this application dies. And that is, I should mention that if your application context is web aware, is something related to web application context, which we will be seeing in the Spring Web MVC chapter in the future, it will actually call the destructions. But if it is a simple application context, if it is a general one, you have to call this function named register shutdown hook. And what it does is that it will tell the JVM that when you are about to finish and die, just give the opportunity to us as application context, and we want to call the destruction methods on all the beans and give the chance to them to clean up. And now if we run it, you'll see that at the last line, after everything has been, after the application is going to die and finish and exit, it calls the destruction function. That is this one. So these two things that we saw are the two interfaces that are built in Spring interfaces, are one way of actually defining and introducing the main lifecycle phases of our bean. And these are absolutely not recommended even by the Spring documentation and officially. And that is because when you implement and extend something from the framework, from the Spring or whatever framework, you are actually coupling your POJO, your class, your business logic, your domain object, whatever. You are coupling this to Spring framework. And that is something that you should actually avoid doing that. So there are other things, other ways that we could do instead of this. And that is, instead of implementing interfaces, we could use some annotations, as you might have guessed. And we will be using the annotations inside the JSR 250. And those are the pre-destroy and post-construct. And those are actually one-to-one, we could say, those are the exact equivalent of these two phases, But this time we are only by introducing the methods only by the annotation, not by implementing some interface. So we could use this post-construct. Again, post-construct means that after the constructor has been called and after the injection points has been satisfied, then call us. And also for the destroy, we have add pre-destroy, and that is before destruction. And if we run it again, you'll see that it is exactly the same. Destroying is being called and this one is being called. And one thing I should mention is that the name doesn't matter when using the annotations, because these were coming from the interfaces. And now because there is no interface, we can say that init, for example, and make it even private. And also the destroy, we could make it private. Making actually these private is a bad idea, again, because we are again coupling this lifecycle functions, which might be necessary to be called. We are coupling this to the Spring, because by changing them to private and only leaning on the annotations, we cannot use this car class outside of the Spring, because these two functions won't be accessible actually. So, but to be actually for the sake of the example, let's just make them private and also change the name. So let's change the name to close and just see that it will work as well. Destroying and after properties has been set. Okay, so this was the second way of introducing our these two functions for the initialization part and for the destruction part. There is this third way of introducing these two functions, and that is without annotations. And that is only able, we can actually do that only when we use the XML annotation. And because we are not exploring and teaching the XML annotation in this series, XML configuration. And because of that, we won't be using that. Of course, with using the Java-based configuration, which we will be seeing in the future episode, instead of annotation, you could tell the construction and initialization functions and methods, you could introduce them with the @bean annotation inside the @bean annotation. And we will be seeing that. But now, there is only two ways that we could do it. One with the post-construct and one with the implementing those interfaces, which were prohibited actually, were not recommended. Okay, so now we are at a good place. We've been introduced to these two life cycle. We can hook our logic to these points in the life cycle of a bean. And if you mix and match these ways that we just explained, for example, have both the interfaces and the annotations or even add the XML related functions, and also introduce a bunch of functions and methods, other methods from inside the bean at bean annotations. I mean, if you mix and match all these, which is a bad idea, again, Spring will try to call them in some order and precedence. And I'm not going to, actually, it has been explained inside the documentation, and I'm not going to explain that precedence, that what will happen if you have multiple initialization defined by multiple ways. And I'm not recommending that. So I'm not going to actually explain that precedence in. So you can go and find about that. But if you see something like that, just in my opinion, and also the Spring, just get rid of, only have a single instruction and destruction point, just only a single one. Because after all, you are designing a class, and a class should be, will be concise. It should be clear that it has a single instruction and destruction point that should be called outside of the Spring as well, and actually making a bunch of mix and matches of those paths and ways brings up the problem of temporal coupling, and this cognitive, we could say, this problem that the developer should understand which one of them should call before which one, if he or she is going to use this class outside of the Spring. And that is a bad idea. Okay, so there is another way of introducing only destruction methods, and hook our logic into the destruction phase of the lifecycle of a bean. And that is by implementing some other interfaces. But this time, because we are implementing interfaces from the official JDK, and we are not coupling ourselves to the framework, that is not actually prohibited. You can use it. It's a valid option. So if you implement the auto closable, which has this close, and let me make it override, which has this single close method. And if I run it, you'll see that it works as well. And if we change it to closable, which is from Java IO, and which doesn't have this throws at the end, again, this one will work as well. So by using these two interfaces and implementing them, because we are not coupling ourselves to the framework, it is a valid and actually viable option, and we can use it. And also, as you know from the Java, the closable and the auto closable has got a bunch of interesting functionality to themselves. When, for example, we use them inside the try catch blocks and other stuff. So if one of your classes has this interface implemented, just leave it as is, because it has already the destruction point. It has already defined the destruction point, and that is a good thing. So that was another way of defining a destruction point in the lifecycle of an object. The last part, I'm going to talk about a bunch of other interfaces that are built inside the Spring, and if you implement them, you will actually get the chance of hooking your object into the lifecycle of the application context, which has the responsibility of defining instances. So I know that we said that implementing an instance, an interface from the Spring framework is a bad idea because we are coupling ourselves. But sometimes when we are going to actually, when the target and the goal is to couple ourselves to the framework, for example, framework authors are trying to create something and on top of the Spring. So when the goal is actually is to couple ourselves, and in that circumstance, we could actually use these interfaces. And there are a bunch of useful interfaces, and one of them is the lifecycle interface. The other one is the smart lifecycle. So if we implement them, and I'm not going to get into too much detail here, I just want to show you that what will happen. So inside the smart lifecycle, you can see that we have this is auto startup and also stop. And also inside the lifecycle, we have start, stop, and running. So these start, stop, and is running, these are the phases of the application context that will actually go through them. And when, for example, an application context starts, it will call the start on all of the beans. And also when it stops, it will call stop on all the beans. Maybe you want to be able to stop some service, for example, when the application context has been stopped for some reason. And that is not that widely used for a typical application, for a typical enterprise application. But it might come handy actually in some situations. There is other interfaces. Actually, there are other interfaces that are prefixed with aware, and the Spring calls them the aware interfaces. For example, the bean name aware. I think that is bean name aware. Let's see, bean name aware. Yeah, bean name aware. So if you want to know what was the bean name what was the bean definition name that you were instantiated off of that, you could actually implement that and get access to the bean name. So this function will be called by the application context. And also, if you want to know, if you want to if you want to get access to the application context itself for whatever reason, we could say it's application context aware. I think, yeah, that is the one. Application context aware, and that we have this function which it will pass the application context to you, and you can actually store it here. You could also do this without implementing an interface and just asking for an application context in one of your fields, an auto wire, or in your constructor or in your setter injection point. But that is another option that you might see when you, for example, see some projects out there in some legacy project. Not legacy project, actually. These things are not that widely used by a typical developer for a typical task. And these are for a special, we should say tasks that are actually for extending the Spring framework for your application, or even providing a new framework. There are other aware-related lifecycles that you could use, and each of them will pass and give you some knowledge about the application context to your bean. And you could actually go and go to the documentation, the official documentation. There is a whole bunch of a list of aware interfaces, and again, those are mostly used by those that know what are they doing, and that they are trying to extend the capability of the Spring framework.